now I'm going to talk about subnetting IPv4 address. This is a very important topic, so let's go. Uh, First thing, what we can say about subnetting is that in TCP/IP, if you want to identify computers, you identify them through their IP address. So this is with TCP/IP protocol. Now each network needs to have its own network address. So you have a one-to-one relation between a network address and the network. So you build a LAN, you build a network, you have the physical hardware, you have everything, but the next step consists of assigning a network address to that network, and then from that network address we generate IP addresses by assigning host address. And by network here we mean LAN or WAN, but in this video I'm going to mention I will stick mainly to LAN. Now the target is to build 4 different networks: network 1, network 2, network 3, network 4. And for this it's required to have 4 different network addresses. As we said here, we need 1 network address per network, so we need 4 different network addresses, but we have a constraint. The constraint is that we have only 1 network address available. So what should we do? We have 1 network address available to build these 4 different LANs. So the solution consists of using the subnetting technique, or subnetting the IP version 4 address. So how to do subnetting? This is very simple. We need to expand the network address to the right. So we have this is a network address 192.168.0.0/24, as we have seen in the previous video. This is a class C network address, and you see here this green byte here in green color is the host address field, and it is 0. So here we are identifying network address, or the address of network. So let's represent this in binary. So we have all the bits in red color represents the network address, and those bits in the green color represents the host address. So subnetting is very simple. It consists of going to the host address field, borrowing enough bits to allow us to create 4 different networks. So if I want to create 4 different networks, how many bits I need to borrow? I will borrow 2. Why? Because with 2 bits we have 4 combinations. 2 to the power 2 is equal to 4. So we can have 4 different combinations: 0, 0, 0, 1, 1, 0, 1, 1. So these 2 bits that belong to the host address field, now they will join the network address field. Now which 2 bits we borrow? The leftmost bits, the bits which are contiguous to the network address field. Of course you cannot borrow bits in the middle or here. Now the bits should be contiguous to the network address field, so we borrow 2 bits because we know with 2 bits we have 4 different combinations. Now these 2 bits that we borrow, well, this is our what is going to constitute our subnet field. So now the network address will expand to the right through the subnet field. What does this mean? It means that the host address field now will shrink from 8 bits to 6 bits. Initially we had 8 bits, but subnetting we gain something and we lose something. What we gained is that we are able to extend our network address to the right, and we can have more network addresses, or what we call subnet addresses, then, because we have now subnet field. But on the other side we reduce number of hosts per subnet, per network. So initially we used to have 8 bits, which give us 2 to the power 8 minus 2 equal to 254 hosts. Now we are left with 6 bits, which means 2 to the power 6 minus 2 is equal to 62 hosts only. So this is a trade-off. We gain something, we lose something. Now let's go to the subnet mask. Subnet mask here is 24/24, which means that we start counting from the left to the right. 8 bits, 8 bits, 8 bits. So we have 28 bits. But since we borrow these 2 bits, we need to mask. We need to mask these 2 bits by setting this bit equal to 1. This bit also is equal to 1. It will mask this bits in the IP address. Now what does this mean? When we set these 2 bits to 1, this means that the equivalent bits in the IP address no longer belong to the host address field anymore. they join the network address. So this is our subnet field, and remaining bits which are set to 0, they point to those bits in the IP address that are still part of the host's address field. So how can we say that the network address is subnetted or subnet address? Through the subnet mask. So the subnet mask is the one which is going to convey that information, and when we convert back the subnet mask, we convert it to the decimal system. It will become 255 255.255.192. Sorry, no, sorry, this the subnet mask should be 255.255.255.192. So here this is a typo, should be something like this, 255, something like in the middle. So this is our new subnet mask. So you see now the subnet mask is different from the previous one. Previous one used to be 255.255.255.0. Now since we borrow these 2 bits, now it should be reflected through the subnet mask, which is now 192. And when we write it in CIDR notation, we have to write 24 plus the 2 bytes which are borrowed. Now it becomes a 26. This is the way we represent our subnet address. So the subnetting technique is very simple. Just go to the host address field, borrow enough bits from the host address field to create to create more network addresses. However, you have to indicate that the bits that you borrowed from the host field no longer belong to the host address field, so you have to mention this through in the subnet mask. So the equivalent bit in subnet mask should be set to 1 as we show here. Now let's do the simple exercise. We start with 192.168.0. No need to convert this to binary, it's okay. Now subnet 0 we have, which means that the following combination in our subnet field 00, and the remaining bits in the host address 6 bits are all set to 1, so in green color. So let's convert this back to decimal. It becomes 192.168.0.0/26. 26, which means it includes 24 bits here in the original network address plus the 2 bits that we borrowed from the host field, which makes 26 bits now for the subnet address. And our subnet mask will be written under this form, 255.255.255.192. Now, since the number of bits in the host address field shrinks from 8 to 6, same thing, so the possible number of hosts is to the power 6 minus 2 equal to 62. So this subnet address now can host a maximum of 62 hosts. And you remember, 2 combinations are not allowed, 0000000, which means network address, and 11111, which means a broadcast address. So another definition of broadcast address is that when all the bits in the host address field are equal to 1, so this is a broadcast address. Now, since we identify our subnet address, which is 192.168.0.0/26, let's now generate the range of IP address. So the range of IP address will start from the smallest value here, 0.0.0.0.0.1, sorry, 0.00001. And the last IP address, so maximum value that we can have with the 6 bits here is 111110. So this is the minimum value, and this is the maximum value. Convert this back to decimal, it becomes 192.168.0.1/26 up to 192.168.0.62/26. Now what about if we set all the bits in the host address field equal to 1? It becomes something like this, and this is our broadcast address for subnet 0. So this is a subnet directed broadcast address for this subnet 0, which means that if you are a member of subnet 0, or if you want to send packets to all hosts in subnet 0, just send your packet to this destination IP address 192.168.0.63. So all computers in the subnet 0 are going to receive it. Now let's go to subnet 1. Same story. In subnet 1, then we move to different combination in the subnet field, which is 01 in blue color. Now when we have this combination here, we convert. Of course, we have to leave all the bits in the host address field to 0, so 6 bits. Let's convert back to decimal. It is now, it becomes 192.168.0.64. So this is subnet address, the address of subnet 1 slash 26 to mention, to indicate that 26 bits now are used to for the subnet address. And when we convert this to the decimal system, it is 255.255.255.192. Same story. How many bits we have in the host address field? 6 bits. Let's compute the combinations. The maximum number of combination is 2 to the power 6 minus 2 equal to 60 hosts. So 60 hosts can be hosted, or 62 devices can be hosted in subnet 2. Now the same story here. We have to generate the range of IP address by playing with the combinations with bits in the host address field. So this is minimum value you can have in host address field, and this is the maximum. You see, this bit is always set to 0. Why? Because if you set it to 1, it means that all the bits in the host address field are equal to 1. In this situation, in this case, we are dealing with a broadcast directed with a subnet directed broadcast address, or simply broadcast address for subnet 1. So when you convert this to decimal, it becomes 192.168.0.127 slash 26. So we have all ways to follow it by number of bits set to 1 in the subnet mask, just to indicate how many bits belong to the network address or subnet address. Now let's go to subnet 2. It's the same story. Now we use a different combination in the subnet field. Now our new combination is 10. As you see, we are left with bits in the host address field, all bits equal to 0. Now let's convert this back to decimal. It's 192.168.0.128 slash 26. Converting now 26, it means 26 bits belong to the network address or subnet address. Of course, convert this to decimal using the old notation. We have 255.255.255.192. Same thing, we can use the same as before to compute how many devices are hosted in subnet 2. Now let's find the range of IP address for subnet 2. So this is our minimum value in the host address field. This is maximum value we can have in the host address value in the host address field. Convert this when we convert this back to decimal, this is what we have. We have 129 and 190. You see now, because we are taking into consideration the value of this of the bits that we have in the subnet field. So this 128, add to it 1, it becomes 129, and 128, add to it this value here, which is 62, then it becomes 192. So always start with an odd number and finish with an even number. Now what about if all bits in host address field are set to 1? Okay, so in this case we are dealing with a broadcast IP address, and which is 192.168.0.191, and this is what's referred here to subnet directed broadcast address. Now subnet 3, the last one, we use the following combination in the subnet field, 11. Same story as before. We have 6 bits in the host address field. Convert this back to decimal, it's going to be 192. So our new subnet address is subnet 3 address is 192.168.0.192 slash 26. The subnet mask is the same as before, as for the other subnets, subnet 0, 1 and 2. 255.255.255.192, and this here the maximum number of hosts that we can have in subnet 3. Now the next step consists of finding the range, or identifying the range for subnet 3. So we start with 192, add to it the minimum value that we can have in the host address field, and also we start with the same thing, 192 plus the maximum value that we can have in the subnet field in the host address field, sorry, to generate the last IP address. So this is the range of IP addresses that we can have in subnet 3. So if you have any IP address, or you have an IP address in this range, so automatically this is subnet 3. But you have also to keep this information by indicating the number of bits set to 1 in the number of bits which are set to 1 in the subnet mask. Now, what about if we put all bits in the host address field equal to 1? Yeah, this is possible again. Remember, now it is a broadcast address. This is called the all subnet broadcast directed broadcast address. And what you notice here previously, now this subnet address looks like a normal broadcast address without subnetting. That's why it's called all subnet directed broadcast address. So if you send a packet, or you send a packet to this destination IP address, this packet is going to be received by subnet 1, by subnet 1, by host in subnet 1, host in subnet 2, host in subnet 3. So as well as host in subnet 0, sorry. Okay, host in subnet 0, subnet 1, subnet 2, subnet 3. That's why it's called all subnet direct broadcast address. Whereas if you send a packet to this destination IP address, the packet will be received by all hosts in subnet 2. Same story. If you send a packet to this destination IP address, the host will be received, or the packet will be received by all hosts in subnet 1. So now imagine you have 4 different subnets: subnet 0, subnet 1, subnet 2, subnet 3, and these subnets are populated by hosts. If you want to allow the host in each one of these 4 subnets to communicate, so the only way to establish communication between those hosts is through a router. Why? Because now you're dealing with completely different networks. So it's true that subnet addresses have been extracted from the same network address. That's true. However, now you create different network addresses, that you assign to different networks. So now you have different networks, and the only way to connect different networks in the world of TCP/IP is through a router. Now we have another exercise. We have an exercise for subnetting. Let's say you are provided with a network address 10.0.0.0/16, and you are required to create 4 different networks. So you're provided with single network address. Normally 4 different networks, they go with each network will have its own network address, but this is what you have, this is what's available. So the solution is to go for IP address subnetting. There's no problem for that. So what we do, the first thing is we take the network address which is provided. So here, how many bits we have? 16 bits. 16 bits. So you see, it's a class A. It's a class A. Normally it should be 8, but here 16, it means it's already subnetted. But what we do, we count the number of bits in the network address. So how many bits we have? 16 bits in red color. And remaining are host address field. But since we are subnetting and we need 4 different networks, what we do, we need to borrow 2 bits, because with 2 bits we can have 4 different combinations. So these are the 2 bits that we borrowed here. This is the place from where we borrow these 2 bits. And as we said, the bits that you borrow for your subnetting should always be the contiguous bits to the network address. Now the remaining bits here that we stay will be in the host address field, are going to be in the host address field. So initially the host address field consisted of 16 bits. Now it shrinks to 14 bits, which means that each subnet now can host maximum of to the power -2 hosts. So you can compute this with a calculator. Now what you can do, in order to generate the different subnet addresses, you can simply play with the combinations in the subnet field. Now the first thing here, let's find the first IP address of the range of IP address that belong to subnet 0. So here we start with a minimum value that we can have now with 14 bits in the host address field. Now once we do this and we fix the combination, the bits in the subnet field to 0, 0, now we convert this to decimal, we get this IP address. So this is the starting IP address for subnet 0. Now we go to the host address field and we put this combination of bits, all ones except this bits here which is left to 0, and convert back to decimal. So we get 0.0.63. So this is 63.254. What is this? This is the last IP address of the range of IP address for subnet 0. Now how to build broadcast address for subnet 0 is very simple. Let's set this bit here to 1. So it becomes something like this. So our broadcast address is simply 10.0.63.255. And in order to show that we are subnetting and reflect back this reflected through we have to use a subnet mask. Our subnet mask initially was 16 bits, 8 bits here, 8 bits here, and since we borrow these 2 bits, we have to fix them and say, okay, these 2 bits no longer belong to the host address field, so we have to set these bits in the equivalent place in the subnet mask, equivalent position, same bit position, subnet mask to 1. Like this, these 2 bits now, they no longer belong to the host address field, they are masked. So we are masking these 2 bits here through the subnet mask. That's why we call it a mask. So which means that all those bits that are left equal to 0 in the subnet mask, they simply point to those bits which belong to the host address field in the network address or IP address. And we convert the subnet mask, we convert it back to decimal. It is then 255, then 255, 192.0. So the subnet mask, same subnet mask will apply to all subnets. Now let's go and create subnet 1. How to generate subnet 1? Very simple. Since our subnet field consists of 2 bits, this is the second combination that we can have with subnet 1, which is 0 and 1. Now these are the bits in the host address field. Let's convert back subnet address to decimal. It becomes 10. It becomes now 10.0.64.0/18. By 18, as you see, we're referring to the fact that we borrow these 2 bits. Now we add 2 bits to 16 originally in the original network address. So now we have our subnet address. What is the first IP address of subnet 1? We simply go to the host address field and we start with the minimum value, which is 1. Convert this back to decimal. Okay, we go now to, for the last IP address, go again to the host address field, set all the bits equal to 1 except this bit here, which is left equal to 0, the least significant bit. Convert this back to decimal. So this is our starting IP address and this is our ending IP address for the range of IP addresses that belong to subnet 1. Now to build the broadcast IP address for subnet 1, it's very simple. Let's all the bits in the host address field equal to 1. Then convert back to decimal. It becomes 10.0.127.255. This is broadcast address for subnet 1, and when convert it to decimal system, it becomes 255.255.192.0, and you notice that is the same as subnet mask for subnet 0. In fact, the subnet mask will be the same for all subnets in this situation. Same story with subnet 2. Okay, we have this. Now we choose this combination, or we go for this combination in the subnet field 10. Leave all these bits here equal to 0 in the host address field. Convert back to decimal. We have now 10.0.128.0/18. Now the first IP address consists of adding whatever we have to the minimum value in the host address field, which is now which make starting IP address 10.0.128.1, and the last IP address we do similar thing, set all bits to 1 except this bit here which is left to 0, and then put this IP address as the last IP address. Of course this is an interval, so this is the first IP address and this is the last IP address, and you have all IP address in between. All those IP address belong to subnet 2. So if you assign any IP address to your host within this range, it means this host belongs to subnet 2, but of course it's not enough. You have also to add the subnet mask, because the subnet mask will is the one which is going to say or to inform you that the equivalent bits here belong to network address as well as the other one. Now for broadcast address, you know I guess that you know by yourself that you have to set all the bits in the host address field equal to 1. And the same story with subnet 3. Set all the bits in the host address in the host field to 11 now. Convert back to decimal, it becomes 10.0.192.0/18. So this is the address of subnet 3, and then the first IP address build it by adding the minimum value in the host address field. Last IP address build it by adding the maximum value that you obtain in the host address field as well. So you have here, this is the minimum value, this is all the first IP address, this is the last IP address, and then you have range all the IP address in between are part of the range. Broadcast IP address set all the bits in host address field equal to 1. Convert this back to decimal, it looks like this, so it looks like that. And subnet mask also is the same as before, so it's very simple. uh, Usually if you want to deal with subnetting, first place you have to convert to binary. Take your IP address, convert it to binary, and then decide how many networks you want to create. You start from specific network address and then say, okay, how many networks you want to create? 4 network, 8 network. What about now if I want to create, let's say, 10 different networks, 10 different networks. So how many bits I need to borrow from the host address field? If I borrow 2 bits, 2 bits, I have 4 combinations. If I borrow 3 bits, I will have a maximum of 8 different combinations, which lead to 8 different networks. So if I want to create 10 different networks, definitely I have to borrow 4 bits from the host address field, because 2 to the power 4 is equal to 16, so this is enough for creating 10 different networks. And of course, the 4 bits that you will borrow will always be the bits which are contiguous to the network address, the leftmost bits, those bits which are closer to the network address, because remaining bits to the right are going to be, or we say, part of the host address field. So subnetting is very easy, but when you work with subnetting, you have really to know how to convert or to deal with binary computations. Now, in the next video, I will be talking about classless and classful IP address.